Hello, this is Andrew with Mr. Remote. In the last video, I talked about this AI Theta and using Home Assistant, or the UI Protect integration inside of Home Assistant to turn this speaker into something that acts like a doorbell chime. In that video, I mentioned that we were going to have a follow-up discussion around the stuff that's on this table, which is the doorbell chimes that I actually ended up building so that I don't have to use that as a doorbell chime, or use the Ubiquiti PoE or Wi-Fi doorbell chimes. So I'm not in love with the way that this thing installs in the back here, and the PoE doorbell chime installs the same way. If you're doing new construction, then that's probably okay because you have access to the back when you're building it, the house. But if you want to retrofit these things, or even like you need to get it off the wall later on, how do you get back there without ripping the wall apart to take out this collar or whatever? So I went down this path because Ubiquiti is Ubiquiti. I stayed on this path because I don't think that this is a good design. It's not a good, well, there's a whole lot of problems with it. We'll just leave it at that. So let's talk about what we got on the table. But before we do that, let's just have a quick recap, in case you haven't watched the other video, about what's going on here. So inside of Home Assistant, you can use the Unify or UI Protect integration to listen for doorbell button presses. I have a very simple automation inside of Home Assistant so that when the doorbell chime becomes occupied, it plays a doorbell noise on all the doorbell chimes that I have situated around the house. Building doorbell chimes, or more specifically, media endpoints inside of Home Assistant, which is what they are, is really simple. You don't need anything that complicated. This is the simplest implementation of that. This is a ESP32 dev. Unit is very popular form factor. You can get these for a few dollars. And then you need a DAC, digital audio converter. This is a MAX98357A, which is a single channel DAC. And then you need a speaker. All this stuff together is maybe like, I don't know, $10 at most. It really depends on what kind of bulk you're buying it in. If you're building a whole bunch of these things off of AliExpress, you can get the price down on this stuff really, really low. I want to say that the DAC is maybe like 80 cents or something like that. Let's take a quick look at what the ESPHome configuration file would look like in order to make this thing work. That's what I have here. The stuff that's here up is just boilerplate. This bit here turns on the web server, which I like because it makes it easier just to kind of see what's going on. That's what this is here. And then this part here is all you need to make this thing into a speaker. The first part is this IS2 audio definition. You can set two of the GPIO pins here for the B clock and LR clock. And then in the media player, you have to define another pin, which is the D out pin. And that's really all there is to it. The other bits here, I like to have an uptime sensor, and then I also like to just kind of have the Wi-Fi stuff, but that's all optional. The only thing you need to have is that. And then assuming everything is set up correctly, you can just test it in the media area. Go find, something that you want to do. Here's a doorbell. And that is super duper simple. Now obviously, or maybe not obviously, obviously to me, I don't want to put a bunch of these things around the house. So the step that came after this led to the stuff that you see over here. This one is basically it's this with a slightly smaller speaker, and instead of using the larger standard dev ESP32, I used a smaller ESP3 device. This is a ESP32-S3 Zero. Do not confuse it with the C3 Zero. I tried that. It does not have the, it's a lower spec processor. It will not work for this. It does not have the CPU capability in order to make this work. I think it's probably because it doesn't have the CPU capability to decode the MP3s that Home Assistant is pushing at it, but I don't really know. I just know that it doesn't work. So the first version of this used a C3 Zero, and then I picked up a bunch of S3 Zeros off of AliExpress. I want to say I paid like $3 or $4 a piece for these, and then that goes in here. So this is the simplest version of it. Obviously, there's a lot of room to make it complicated, but if you just want it simple, that's what this is. I'm going to put the STL files for all this stuff up somewhere, and then I'll put the code, those, the ESPHome YAML things up as well. You all can do whatever you want with it. After I built this one, I decided that if I was going to deploy doorbell chimes all over the house, I ought to make them a little bit more feature-rich than just a doorbell chime or a media speaker or whatever. And that's when I got a bunch of these guys. This is a BME 680. It's an air quality sensor. These two, and there's another version of this, a more complicated version of this, that has this air quality sensor in it. The long-term goal with this air quality sensor is that I want to put one of these devices in every room in the house, so that I can monitor the air quality in every room in the house, so that in our next house, we're building a house that will have an ERV in it, that I want to use the air quality sensors around the house to make intelligent decisions around triggering recirculation or ventilation modes on the ERV. I haven't gotten around to building that. Right now I just have these things all over the house, and eventually when I find some time, I'm going to figure out how to link all that together to make these more intelligent decisions. This is very standard doorbell chimey looking thing. This is actually based around the Ubiquiti PoE Pro, or what is this thing actually called? It says Inter PoE. It's the H438 model. It does PoE. It has an SD card reader on it, which I don't want. This is actually a complicated device. There aren't that many pins on it, but there are just enough pins to do the things I want to do, which is I want to put a fan in here. So there's a fan. I want to put the air quality sensor, and then obviously I need the DAC so that I can make it into a doorbell chime, and then everything is powered off of PoE. So these guys, it's just a early print of one of the cases, go on the wall. So it would kind of go up on the wall, like way up where you normally put a doorbell chime, and then just run Ethernet there and power everything off of Ethernet on there. Ethernet goes in the back, and then there's some holes to mount. So that is very easy to stick on the wall. And you don't need to have access to the back of the wall, except that first time when you just run Ethernet into there, and then you plug it in, and then you're done. And then you get a doorbell chime that is PoE powered, and it's also an air quality sensor. And I put a fan in here. I don't know how important the fan is. It was more of a, maybe I should put a fan in there. Because I have other models of this doorbell chime air quality sensor thing that don't have a fan. Like this one does not have a fan. The air quality version of this does not have a fan. This is a more complicated version of the doorbell chime air quality sensor. This is based around the LilyGo T4Q367. I have a nearly identical model or version of this based around the LilyGo T4Q368. The Q367, this one, do not buy it. It sucks. The Wi-Fi sucks. The display sucks. It has slightly better dots per inch, but it has massive light bleed around the sides, so it is not, I can't use it in any room that gets dark. Where I can use the Q368, I have that one actually is up in my bedroom, and I have some smart features for this model, or this, this idea of a Chime air quality device where it changes the color of the text on here and changes the brightness of the display during certain times of the day. And we're going to take a quick look at that. So here is the website, the ESPHome website that you get when you turn it on. Now, like I said, I like to put this on for everything, but here it is super important for this guy and the much better Q368 because that's how you configure how it behaves. The BME 680, it has a temperature offset. It has to do with the way that the thing works. It's super important that you figure that out. In most cases, the temperature offset is going to be like in the 3 to 4 range. The way that you do that is that you put it in a place, you let it sit there, and then if you have you need some way to take the temperature of the room or objects in the room. I use an IR thermometer. You can also just, if you have some other way to do that. And then you can just adjust the offset so that you get it to match the room temperature, and then you're good to go for forever. I like to see temperature in Fahrenheit because I live in the US. So that is a setting. I also like that you can change the way that the VOCs are displayed. This is the backlight control aspect to it. There's different ways that I have it set up to work. I really only use it in day-night mode for both of these. How that works is that it's driven by these display on time, display off time settings. So basically from 9:30 at night to 7 a.m., it ramps the display brightness down to 20% and then changes the text color to red. And I can just show you what that looks like here if I just change the day text color to red. And we should just see this thing drop to red. And it's really that simple for the configuration. Should go, yeah, it went back to white. Background color, black, you can control it if you want to. This feels like temperature. So there was a lot of real estate on here. I have it showing the date, the time, and then the current weather from Open Weather Map. And then down here is where it shows the air quality stats from the BME 680 in there. So the feels like temperature is what you see here, and you can change it to the actual temperature. I just don't really care what it actually is. I care more what what it feels like it is, because I live in Chicago. Chicago summers are very, very humid, so the feels like is just a better way to do it. And then I have the wind speed and direction, and then there's a little icon here that tells you what the current weather is. So like right now it's sunny, and I can look outside and yes, it is sunny. The code for this device is understandably way more complicated than the simple one. I probably already said I'm going to put all this stuff up, share it somewhere, probably on GitHub or something, so you don't have to type furiously as I walk through this. Like the other one, everything above Captive Portal is just boilerplate. It's kind of how you set up stuff in ESPHome. Although I should mention that I recommend going with these options because the Wi-Fi kind of sucks. And I actually use these settings on the Q368 as well. I just don't need them as much. The Wi-Fi in there is also not 100% reliable, but it's fine-ish. Power save, you want to turn that off. Fast reconnect, true. Reboot, timeout. The default is 15 minutes. This thing just bounces every 15 minutes if you leave it at 15 minutes. And then if you just turn it off, because the Wi-Fi module just craps itself, it will go offline and then you have to manually yank the power. So I do have it set to 30 minutes. It's kind of a happy medium. There's a little bit more leeway, but it also will bounce itself if it drops off the network for too long. And then the use address just gives it a address that it tries to grab every time, because I use static DHCP assignments for most of my Internet of Things devices. There's a whole bunch of like really complicated stuff. I probably don't need all these globals. I was trying to figure out how that works. This image part is how you get these images here. Oh, look. Now it's cloudy. Oh, one thing I forgot to say about these, the Q367, Q368, they have buttons on the front. And so I do have these set up to do things. I want to say this raises and this lowers the brightness, and then this changes the brightness mode or something like that. That's all configurable in the buttons section over here, which is what this is here. I never use these. I thought they would be useful when I first got the device, and so I coded it up and figured out how to print button things in there, but I never use them now. Here is where we have our media player, so it's a doorbell chime. This bit here is where you define the air quality sensor. It runs on the I2C bus, not to be confused with the I2S audio bus. I2C is kind of interesting. That's something that's worth looking into if you get into this kind of stuff. I haven't done much with running multiple devices or multiple sensors on a single I2C bus, but you can, which makes it pretty cool. There's not a whole lot here to know. One thing that I forgot to mention is that for the DAC, if you want to control the gain or the audio volume, you do that by attaching a ground pin to the gain pin, and then you use various resistors or different kinds of resistors to determine what the gain is. I want this thing to be as loud as it can be, so I went with whatever resistor. I think it's 100K resistor, and so this is the only really complicated thing about making one of these chimes, is that if you want to control the gain, you do need to solder a resistor in line in a wire and then connect the gain to a ground pin. So the air quality stuff, pretty straightforward. There's lots of examples on how to do this. I don't know that there's really anything else to walk through here. This is the code that draws the display. It's probably more complicated than it needs to be. This was the first time I used ESPHome, so I probably brute forced some things that I didn't need to brute force, just so I could keep it really, really simple. So this part here is actually kind of interesting. This is how you flip between the different modes for the display, for night mode or day mode, because it figures out what time it is. And then are you within these time, a day time or a night time? Hopefully that wasn't too long-winded. If you decide to build any of this stuff, you're going to need a couple things besides a soldering iron, maybe a multimeter, and the different sensor SoC components. You're going to need a variety pack of M2 screws. Except for this, you're going to need 2 M3 screws for the fan, I think. You can buy all this stuff off of Amazon. I'll put some links in there. And then you just need to get, the fan, the wires, the different components that you need. And then there's one thing that is kind of a little bit different, because I power this with one of these USB-C, I don't really know what to call it, breakout dummy. It says USB-C downstream. Basically, it's just a USB-C port that exposes the power and data pins from USB-C to devices. I tapped the power on here so that I can have a nice power inlet, because the power for this guy is actually on the side over here, and it's just kind of, why would you power it that way? So a couple bucks on Adafruit, you get a whole bunch of these USB-C ports. You can use micro USB too. I just trying to get all the micro USB out of my life. And then you will need a 3D printer. This is a Bamboo Lab 3D printer. It's very nice. It's a P1S. You don't need to have a super fancy one. Actually, you don't even need to have one. A lot of libraries have printers, so you just need to bring an STL on, like a SD card or thumb drive or something, and then run it there. But if you do decide to get a 3D printer on your own, the Bamboo Lab ones are super nice. This is the mid-range one. There's the A is the entry, and that's pretty cheap. I want to say it's like a couple $100. And then, at the top end, you can spend over $1,000. I know they got a little rambly. I hope it wasn't too rambly. I hope you found it useful. And if you have any questions or comments or anything, drop them below or send me an email at andrew@missingremote.com, and I will do my best to answer your questions. Cheers. Now, I probably shouldn't say this, but I don't really see a reason for me personally to buy any of the Ubiquiti Chime hardware. The PoE one, they just made that available. You used to only be able to get it as a bundle as part of the G4 Professional doorbell. Is $80 a la carte or $79 a la carte. If you can get it, it's always out of stock. Whereas this thing, I want to say I built this for $25 or something like that, maybe $30. And it does, and that's with like the air quality stuff in there, and the installation is so much easier. And then for the Wi-Fi one, it's even more of a slam dunk to just get one of these, because you buy these ESP32-S3 Zero things off of AliExpress for $3 or $4. You get a DAC for 80 cents, and you get a speaker for a couple bucks. You can build these things maybe for 10 bucks, maybe $12, something like that, and then you can put them everywhere, versus whatever they're charging for the Ubiquiti Chime. Anyway, I'm done talking now. Enjoy.